capsular hydrostatic pressure and good. Good. Okay, so that's the filtration process. So now we go to the PCT and we have reabsorption. Okay, so I'm trying to think. I'm not going to talk about the channels, although we could. We'll just sort of look at big picture what's being reabsorbed, I think. Does that work? Mm-hmm. Yeah. Okay. Yeah. So then we have sodium being reabsorbed, and we could do so. And then if we were to blow this up, well, we could do it, I guess.
Yeah, you have the fluid and the smell.
So what this is going to show is the actual. This is the cell.
Okay.
So these are the different cells of the tubule, which is blown way up. Okay, so sodium goes across that way through facilitated diffusion, and here through the sodium potassium pump. Okay, so then we also have to talk about the movement. And it's not really secretion. We didn't talk about what happens to potassium after that and getting in here, but basically, you know, there's the pump. So then we also have, when this occurs, that causes other things to move, right? So that also is going to cause water to move. That's also going to cause the chloride.
That could be any anion.
Yeah, there's other ones too.
Okay.
Okay, then we also have the co and counter transport. So with sodium, we also have the co-transport with the glucose and the amino acids. And then again, those are continuing on into the blood.
The facilitated diffusion? Okay.
Exactly,
Okay.
facilitated diffusion.
The hydrogen's back.
And then, yeah, then we have the counter transport. What else? Okay, we'll just do that one. So then we also have the counter transport. So this, I'm just thinking, so this is PCT secretion. Right, the hydrogen is occurring. So this part of it is what we would describe here. And that's good. And that's exchanged again for the sodium.
The other one was carbon dioxide.
I know. See, I'm trying to. I had thought more about how to organize this. I would maybe made it a little nicer. So remember we talked about those are the three main mechanisms, and then this was sort of like it also drives this secondary active transport of carbon dioxide. That's kind of in its own category, just in that it's not. I mean, it is driven by sodium here, but it happens more for pH balance and things. So we could draw that on there.
Who was secondary transport on there, Erica? You did a secondary transport. Was that the Was that the chloride in the water? You have facilitated diffusion for the glucose and the amino acids. Sodium potassium pump for the sodium and the potassium. And what about the water and the chloride there? Was that?
So secondary active transport.
That's you.
Oh, okay. Family.
Joey answered.
No. Okay, so
The co-transports in the counter?
yes, the co and counter are a type of secondary active transport. This is primary active transport, right? The sodium potassium.
Right.
Okay. So if we did just want to draw the CO2 as kind of its own different thing, CO2 diffuses in, and then that's the equation with carbonic anhydrase. And so from there, then that's what produces the bicarbonate. Whoops. And the bicarbonate will continue on with sodium. But it's, like I said, it's kind of its own. So that's all the reabsorption secretion here. And then if we go to the loop of Henle, what's leaving the descending loop? Okay, good. This is water. And then if we were to draw just the concentration, so, you know, it's 300 milliosmoles, and as it gets deeper into the medulla, as water leaves, it gets really concentrated. Well, that's convenient because then we have these pumps here, right? Sodium, a sodium chloride, and now because this is so concentrated in sodium and chloride, those will leave and then start to make this concentrated, which gets this positive feedback loop going, where now water is exiting out. Okay, so that's the countercurrent multiplication. And then, if we move on, this is more what we talked about after the break. At the DCT, this involves the regulation, right? So we've got ADH, and aldosterone. I think how to organize this. Because the DCT, we have secretion and we have reabsorption, right?
Yeah.
So ADH is going to cause, is going to cause what to happen?
Aquaporin,
Okay, good.
so
So,
that water
It's
can.
gonna be water retention.
right. So that's going to create, if we draw the cells again, so that's going to cause the insertion of the aquaporins. And so that causes, so we'll put, so this is ADH, right, in the blood.
Right.
And then that causes water
To come up out of there.
reabsorption. Okay, so DCT reabsorption of water, and we're going to have another reabsorption. What was the other one? What does aldosterone promote the reabsorption of?
Sodium.
Okay, good. Sodium. Okay, so aldosterone, again, it's traveling in the blood. It goes to the cells, the DCT cells, and that causes then, right, the carriers and channels. And so specifically, we have the sodium-potassium pump, right, in the basolateral side. So which way is sodium going? Right, this way. Potassium, I'm sorry, we drew that the opposite direction.
Right.
Other way around, sorry. Okay, so,
Sodium's going into the blood,
good.
right?
Sodium is going into the blood, and potassium is being excreted. And then we just have the potassium and sodium leak channels, right?
On this side.
So, sodium and potassium.
Now are those leak okay. So this is the lumen here, right? That we're looking at?
Exactly, yeah, I
Okay,
just
okay.
made that cell
Just
layer
check it, okay,
larger.
okay.
It could look a lot
Okay,
bigger.
no, it's perfect. I was just checking for a second.
So there's the sodium reabsorption, and then we also have, I should say this is all reabsorption, right?
Mm-hmm.
And then at the DCT, we have secretion. So far we've seen of potassium. And then what we talked about today in this complicated figure here, where you're just focusing.
That is so complicated. I'm sorry. I looked
We're
like a
just-
deer caught in the headlights when you threw that up. It was just like, wow. Just a lot going on, that's all.
Yeah,
It's not that complicated once you understand it, but there's just a lot going on in that one
Mhm.
figure.
Mm-hmm. So we've got, oops, wrong way. We've got the hydrogen that's going to be secreted from the bloodstream, right? So this is in a pH issue. So the first way, so this is in the reverse direction, right? That's why you can use there. So it's being exchanged for sodium here in the countertransport and here. So there's secretion now of potassium and of hydrogen. And I should say this is the DCT and the collecting duct.
So we want to get rid of hydrogens out of the blood because it affects pH, right? Is that
Exactly.
why we're doing?
Mm-hmm. Very good.
Okay.
Yeah. And then all of this, you know, is going to produce the urine, so in the
Mhm.
presence or absence. So if we say that we are in the presence of ADH,
Mhm.
so as it goes up here and the salts leave, it's less.
Mhm.
But in the presence of ADH, now as it's going out, it becomes very, very concentrated.
That was awesome. By the way.
Well, if I would have thought more about it, it wouldn't be so messy. I was just gonna say, I took some of your dry ones and put them here,
Can
and
you
then
send that to me?
I did get into that. Yeah, I'm gonna go.
They're all
through
kind of
these.
mixed.
Yeah, so I'll pull out the ones that are. Oh, okay.
Yeah. Oh yeah.
I need to take a picture of it. I should have grabbed mine.
She done?
Oh,
Oh.
see.